Okay, here we've got a cumulative frequency graph. And I've actually got the coordinates for you to plot all the points that you need to make a smooth curve that usually forms like a kind of extended S. We want to go to the maximum, okay, so between 30 and 40 there are 6 people up to 40 minutes, so that's the coordinate 46. We've got 50, 20, etc, etc. So I'm going to plot these, okay. So the first one, as you can see, was 40 and 6. It seems that each square is going up in 2, isn't it? Okay, so that's 2, 4, 6. And I'm going to plot all these points, and do it the next or something like that, something very clearly visible for the examiner, okay, because that's what they'll be marking. Now, when you look at these coordinates, you're not going to the midpoint. We're not working out an estimate for the mean, or we're not working out an estimate for anything else. Okay, we're just plotting cumulative frequency. Okay, and you can see now we have to. Now, do not use a ruler for this bit. That's the best you can do. Make a nice smooth curve all the way through these points. Okay, and that should be good enough to get full marks for that particular part. Okay, so this is our 100 runners, and that's our cumulative frequency graph. Now it says use your graph to find an estimate for the median length of time that adults went for a walk. Well, there's 100 walkers, and the median will be the 50th length of time that a 50th walker takes. Okay, so let's go to the 50th walker. Okay, and that's cumulative frequency. 50th walker will be there. Now you must use a ruler and draw this line on. You must do this, okay? Otherwise you will be penalised. Okay, so the 50th walker, fix the graph there, and you draw a line down, all straight, perpendicular to the x-axis, and that goes down to, well, it looks to me like 58. 58 or 59, something like that. Okay, 59, sorry. 59. Right, so I'm going to write 59 minutes there. And, oops, I need to bring that down to the camera, sorry about that. And now, one of the 100 adults is chosen at random. Use your graph to find an estimate for the probability that this adult went for a walk for more than 72 minutes. So let's go to my graph and draw a line up from 72 minutes. Okay, so looking at my graph, I go to 72 minutes, the time it's actually told us on the x-axis. So 72, draw up that line until you hit the graph, do the best you can. Okay, and then we're going to go across from that point where it hits my graph, and that will tell me which runner or walker 82, 84, 86. Right, so the 86th walker took an estimated 72 minutes. So that means if you're, well, how many numbers? 100 runners, take away 86 means that there's 14 runners that took longer than 72 minutes. So 14 walkers took longer than 72 minutes. So that's 14 out of the 100. And of course, 14 out of 100 is 0.14, or you could write it as a fraction. I'd prefer fractions, but you don't have to do it like this. You could write 0.14. I'm going to write 14 out of 100, which is the same as 7 out of 50. So I think the answer's 7/50ths, or about 0.14 probability of taking more than 72 minutes. So let's have a little look at the examiner's report. Do pause. Yeah, I think we definitely, if you've gone to the trouble of drawing a graph, then use the graph. I wouldn't use linear interpolation. Okay, so correct diagram, 58, 59, good, and 14 out of 100, lovely. It's okay.